Okay, so this is going to be a set of notes on conditional probabilities. So what a conditional probability is, so let's get this down here, conditional probability. What a conditional probability is basically the probability of one event occurring given that another event has already occurred. So if I write the probability of B given A, this is the probability that B will occur given that A has already happened. And we get a formula for this. This says that this is the probability of A and B over the probability of A. Okay. So in order to do this, I want to work from a little bit of an example, and we're going to build a two-way table, and we're going to use this formula to show how these conditional probabilities work. Okay, so let's get our two-way table up here. We're going to go into a situation dealing with pregnancy testing. Seems like pretty easy to wrap our heads around here. The test can either come out as positive, indicating that there is a pregnancy, or negative, indicating that there's not. And the subject hopefully is either pregnant or not pregnant. All right, so let's say we got 99 people in our test group here. 80 of them are pregnant and test positive. 5 of them are pregnant and test negative. 3 are not pregnant and test positive. 11 are not pregnant and test negative. All right, so let's say we want to calculate the probability of someone who is pregnant getting a positive test. So this is the probability of being positive given pregnant. So according to our rule here, this should be the probability of positive and pregnant over the probability of pregnant. Okay, so there's 99 people in our test. The number that are positive and pregnant are 80 out of 99. The number of people that are just pregnant, okay, so there's 80 there and there's 5 there. So that's 85 out of 99. A little bit of math here. That's dividing by a fraction, so we multiply by the reciprocal. Something interesting happens here. Those 99s cancel. Right? Oh, that shouldn't be 88. That should be 80. 80. 80 over 99. 99 over 85. So that's going to give me 80 over 85. And if you were to jump on a calculator, that comes out as approximately 0.941. So 94.1% of the time, this thing's getting it right if the person is pregnant. Realistically, though, we need the other one. We need to know what is the probability that you are pregnant if you have gotten a positive test result. It'll be slightly different, right? Because this is the probability of pregnant and positive given positive. Okay. So pregnant and positive is still 80 out of 99. That has not changed. Okay, the probability of getting a positive result are these 83 people. They've gotten the positive result. So that's 83 out of 99, right? So again, multiplying by the reciprocal, the 99s cancel. Gives me 80 out of 83. And if I take that to a decimal, I get 0.964, which is even better, right? Because this was 94.1% of the time we were getting the right result. But if someone has a positive result, there's a 96.4% chance that they are in fact pregnant. All right. So this is like how to do calculating conditional probabilities from a two-way table. Okay, so we also talk about sometimes independent events. We want to know if they're independent. This is different from being disjoint or mutually exclusive. Independent means that if one of them has happened, it does not change the probability of the other one happening. So this means that if events are independent, so if independent, the following should be true. The probability of A given B should equal the probability of A. And the probability of B given A should just simply equal the probability of B. If these two things are true, then we can say that A and B are independent. All right, so there's your basic idea of conditional probabilities, and we'll play with these for a little bit in class here.